The idea is to make use of area that normally you cannot use in GFA term to become usable. Now, there is an interesting, because of all these design and environmental issues and solutions, the school actually has 20% more teaching area than a government school for free. So what does the canopy do? It has to take away the heat, the direct solar heat gain, and it has to let in natural light. And then it will be able, so the building fabric doesn't absorb too much heat and therefore require too much air conditioning to reject the heat. Right. Because you have a canopy, the concept is like a courtyard. Hot air always rises. So we wanted the canopy to have a temperature differentiation between the top surface and its underside, so that it work almost like an aerofoil, because there is a temperature difference, there will be air pressure difference, and as a result the air moves, and so it induces a ventilation or air movement. And apart from taking the rain, keeping the radiant heat out, and generating an air movement, we wanted the heat stack effect inside under the canopy to remove the heat normally absorbed by the concrete ground, right? Because during the day the concrete floor absorb a lot of heat and they radiate heat to the space, and so we wanted that heat to escape and draw upwards and then allow the airflow to take it away. We wanted the canopy to allow 94% of natural light through, because we don't want to create a very dark central space that you ended up having to switch on light in the daytime. But when we started to do very simple calculation, when you allow the natural light to come through at 94%, that means you are also allowing all the UV and the infrared to come in as well. That means the atrium becomes excessively hot. So we ended up having to frit the ETFE on the top to reduce the natural light through to 63%, I can't remember, of opacity. Now then, finally the BD have to approve the design, and EMB then start questioning, why do we have this canopy? Because even the services engineer couldn't understand what this canopy will do. Now, this is what a good engineer opposed to a bad engineer. We argue that the canopy has to have an insulation factor in order to have its top surface and its bottom surface being different in temperature. They say ambient temperature is ambient temperature, so therefore it's the same. But we say surface temperature is always higher than ambient by a great deal, right? If you go to the roof, you put your thermometer on a table as opposed to a thermometer under the table, there's a big difference in temperature. And so we think if you have an insulated canopy that allows light to come through, but yet it has an air bubble in it to make the difference in temperature, there will be airflow because there is a delta T. So the engineer couldn't calculate it, so we ended up that we went to London, or we had to employ this consultant in London to do the CFD. So we gave him a brief for three things. One, the thermal performance, but the thermal performance, we don't want measurement of temperature of building fabric. We want him to tell us the thermal comfort temperature. And so that is the first brief. The second brief is the wind flow. We wanted to know with this canopy whether there is an increase in air flow rate as a result of having a canopy with wind and without wind, without prevailing wind of a day. In other words, a very still day, what would happen? The third thing is the daylight factor. you're going to get at the bottom of the atrium. So in between the two blocks, at the very bottom, what do you get in terms of natural? So these slides, which I won't go into in detail, on the left-hand side is without a canopy, on the right-hand side is with a canopy. And you can see the temperature gradient changes phenomenally.
Sorry, the green is comfortable. I mean, the color differentiation is the you mentioned about the thermal comfort temperature, right?
Yeah.
So thermal comfort temperature is indicating the color, because we normally don't measure the thermal comfort temperature, right?
No, we don't. You can't.
Yeah.
And thermal comfort is just a perception, but they measure radiant heat, radiant heat temperature. Yeah.
Right.
Now, and then you can see the hot layer stay above the canopy. I mean, the canopy is this very faint line here.
Yes.
Very faint line here. It stay up there, and so therefore makes your cooler air much lower. But what is interesting, I don't know why, the really low temperature is in this corner when you don't have the canopy. I couldn't explain it. I couldn't understand why there is so much lower. But your rooftop has gone from yellow to green. So it goes from 53 degree down to 51 degree, or between the border of 49 to 53. So there is a 4 to 6 degrees centigrade of temperature difference. And this canopy is just simply an air-filled bubble made out of plastic. Then the wind flow, based on prevailing wind, the airspeed increases by 2 meters per second. And even on a still day, there is a very light air movement of just under 1 meter per second. So it means it induces a certain amount of air movement that allow you to feel there is convection. And the most important thing is you can see how the air get entrenched and then get exhausted out. So this is very important that because of this canopy, it creates a funnel effect in which the heat is removed under prevailing wind situation.
Right. Actually, I was going to ask you, because we have a term called the canyon effect, which is the air at the bottom of the two very narrow blocks have a sterile kind of the air doesn't move.
It's stagnant.
Then actually this one I saw from the second diagram, it moves, right?
Yeah.
So that's because the canopy has a temperature difference between the top and bottom, and then to generate this kind of air movement.
Yeah. Okay. Now we couldn't prove this until this engineer come along, and by then the building is almost ready for construction. So we have been doing this completely on faith. So the air leaks out, but it does not deflate. All it does is just the pump just keep pumping air into it to compensate. But to repair it, all it takes is like if your children have a float in your arm, if you have a puncture, all it takes is a piece of plastic, put some glue on it, and stick on it. It's exactly that. They just find a piece of same ETFE, cut it into shape, put some glue, stick it on, and that's it. So maintenance-wise, it's very, very low. Now with this material, the manufacturer is guaranteeing 25 years. So maintenance-wise, they hardly need cleaning because it's if you are 65% opaque, even if you have dirt on it, you wouldn't probably notice so much. Right. And because it's Teflon, you rely on the rain to wash it off. Yeah. But the most interesting thing that we found is that it can support a lot of weight on this thing. So you can actually walk on it. So if you want to do maintenance, you can just simply walk on the pillow. Of course you need a safety harness, but you can support very heavy load. And under fire, the melting point of ETFE is 270 something degree, way before the steel yield. So when there is a fire under the canopy, the smoke just simply disappear, the heat just simply disappear, isn't there together to melt the steel. So if I was right, I can't remember, I think the steelwork isn't fire rated, that we don't have to put fire paint on the steelwork. There is, I think, also no sprinkler in the steelwork. So I think that I need to check, I could be wrong, but I seem to remember there is no sprinkler in the building. And we were also trying to push the school to go a bit more high tech. We wanted to go for a 2 air chamber pillow. So you have basically 3 skin, the outer skin, a middle skin, and the lower skin. You have a pattern on the top skin, and you have a similar pattern, but offset in the middle skin. So you just have to vary the air pressure into the 2 chamber. You can bring the middle skin upwards to block out the light. So when you have a pattern like a let's say a domino 5, but if you slip the domino 5 at 45 degrees, the gap between them is completely filled, right? So you just have to change the air pressure and move the middle layer upwards. You can completely close out the light. But when you want the light, you put the pressure back in, and then it open up again, so it let the light in.